Today I've got this interesting physics problem about collisions, and this one has a particularly beautiful solution. So I've got these two balls. One ball mass little m, other ball mass big M. This one has a velocity v. That's the initial setup. So this is before collision. And after collision, this is what happens. The two balls move away with equal and opposite velocity. So this is minus v prime, and that's v prime. Ball M, ball big M. Okay. Now, the question here is one, how can this happen? So specifically, what is the relationship? What is relationship between little m and big M? All right, and two, what is v prime? Okay, the after collision velocities. Now, if you think about this, this ball is kind of reflected off that one. So I think it's pretty clear that this one's going to be heavier. How much heavier? Well, we have to calculate this kind of ratio, m over m. And that's going to tell us the answer to part one. How can this happen? Well, once we know big M over little m, we kind of know. So to do these type of problems, the standard technique is to first examine momentum before and after, and then energy. So let's start with momentum. Before, total momentum is little m times v. And, well, momentum after, this is positive direction, that's negative. Momentum's a vector, so we have to subtract these things. It's big M v going in the positive direction minus little m, v prime. Factor out v prime, I have big M minus little m. Let us divide by little m, v prime, big M over m minus 1. Now, I'm going to make this definition here. U is big M over little m, like that, okay? See that? All right. So, I'm going to use this factor now. V is v prime, u minus 1. And there's my solution. Well, there's my momentum analysis. Okay, that's part of my solution. That's part of how it's going to go. And let's go to the next part, the energy analysis. Now, kinetic energy before and after must be equal. No heat is evolved. Nothing has changed in that regard. The total amount of kinetic energy coming in equals total amount of kinetic energy coming out because it's elastic. So 1/2 mv squared is equal to 1/2 little m v prime squared plus 1/2 big M v prime squared. Okay, now energy, of course, is a scalar quantity. There's no plus or minus to it, no direction. All right, let's cancel out these things. Let's also divide by m, and I get v prime squared plus u v prime squared. So I can factor this out. V prime squared u plus 1. There we go. Very nice. Now look here, I have a v here and I have v here. So if I square this thing, v squared is v prime squared u minus 1 squared. I can now equate these two, all right, like so. Equate this with this because they're equal to the same thing, v squared, see? So let's do that. Okay, let's remember how this goes. It's v prime squared u minus 1 squared equals v prime squared u plus 1. And I get this remarkable, absolutely remarkable equation. Look at this. Have you ever seen something like that? I mean, it's really beautiful. That's really something. Really amazing. Beautiful algebraic condition. All right, let's solve this. u squared plus 1 minus 2u equals u plus 1. This cancels with this, and I get u squared equals 3. u equals 3. If u equals 3, well, what does that imply? U equals 3 equals big M over little m. Big M must be 3 little m. There we go. Incredible. Incredible. And so, look at this. We have solved this part. This is 3 little m. This is 3 times heavier than this one. Is that what your intuition told you? Okay. Sometimes intuition, although a very, very powerful faculty of the human mind, can really lead you in a weird direction when you're doing physics. All right, so u is 3. Now we have to find out one more thing. We have to find out what's this v prime. To do that, we use this formula here. V prime equals v over u minus 1, and u minus 1 is 2. So we have completed everything. This velocity here is initial velocity by 2. What a beautiful problem. In order for this scattering to happen, like so, equal and opposite velocities, the big M mass has to be 3 times heavier than the little m, and the scattered velocities after the collision will be 1/2 the original velocity of the little m ball. Beautiful. Okay, if you like this and you want to see more such physics problems, great. I'll do more. Click like on the video, subscribe for more amazing physics problems.